Hello, my name is Todd Evans, and I am a Level 2 Product Support Engineer at Cole Morgan. And this video series is an introduction to the AKD Ethernet IP servo drive. Welcome to video 16 of the AKD Ethernet IP video series. This video will cover explicit messaging. Explicit messaging is on-demand access since the read or write takes place when you request it or when it's triggered. It's independent of the cyclic data of the command and response assemblies, and therefore does not conflict with a command such as an add-on instruction that is executing if an explicit message is called. These are major benefits of using explicit messaging for parameter access that isn't required every scan or very often. From the AKD Ethernet IP Communications Manual, explicit messaging uses parameter class F hex. From the AKD Ethernet IP Communication Manual, explicit messaging performs three possible functions: read a parameter value, write a parameter value, or execute a command parameter. You can see from the screenshot below, it shows that section of the manual and it has descriptions and definitions. So please refer to the manual for more details. Keep in mind these read-write parameter methods are completely different than the AKD read parameter and AKD write parameter add-on instructions, which use command type hex 1F. So to read a parameter with explicit messaging, the class will be set to hex F, the service is hex E for read, the attribute is 1, and the instance number will be the AKD parameter instance number from the Appendix B of the manual, or lookup using Workbench by navigating to Device Settings, Communications, Ethernet IP, and then the Command or Response tabs. To write a parameter using explicit messaging, the class will be hex F, the service will be hex 10 for write, the attribute will be 1, and the instance number will be the AKD parameter instance number from Appendix B of the manual, or lookup using the Workbench GUI by navigating to Device Settings, Communications, Ethernet IP, and the Command or Response tabs. To execute a command parameter using explicit messaging, the class will be hex F, the service will be hex 10 write, the attribute will be 1, and the instance number will be the AKD parameter instance number from Appendix B of the manual, or look up using Workbench by navigating to Device Settings, Communications, Ethernet IP, and then the Command or Response tabs. The value to send will be 1. An example of a command parameter would be the home.move or the drive.clearFalse or CLRFAULTS. Both the AKD Ethernet IP Communications and the AKD Ethernet IP RS Logix Communication Manuals have an Appendix B for parameter listing for the instance number and data size lookup. At the time of this presentation, the 32-bit version of the 64-bit 8-byte parameters are not in the listing. As aforementioned, another way to find the instance number is using the Workbench GUI. So when you navigate to Device Settings, Communications, Ethernet IP, Command or Response tabs, when you click Configure, you will see the screen that's shown below. This method allows to look up the 32-bit version or 4-byte of the 8-byte parameter instances. For example, looking at the screenshot below, if you look at instance 13, the analog out.pscale is an 8-byte instance. But if you look at the next instance number after that, which is instance 14, you'll see that it also is the aout.pscale, but in parentheses the 32-bit version in 4 bytes. Data sizes and tag types. Note the following table in regards to tag dimensions in the AV PLC versus the AKD. On the left it shows the AKD instance data type for command 1 byte, 1 byte sign, 2 byte, and so forth. On the right side it shows the AV PLC tag type to copy the value into, or to for a write, the value that would hold the value to write. Note the tag type rail is not applicable with the AKD Ethernet IP parameters. Explicit messaging in RS Logix 5000 uses the MSG or message instruction. Here's an example. Read the home dot distance, DIST. From the Workbench GUI, you can look up an instance in the dynamic response mapping table. Instance 200 is the home.dist 32-bit version, and the data size is 4 bytes signed. From the PLC, once you've added an MSG instruction into the ladder, then you can configure it, which we'll demonstrate later in this video. But you'll note that when you configure the MSG instruction, then the message type is SIP generic, and the service type, if we're going to do a read, will be parameter read. The service code is E class F attribute 1, which we had described earlier, and then the instance is the instance number of the parameter we want to read. And then you'll notice the destination element, there's a tag that has been declared to hold the value when this explicit message is sent and successfully executes and the value is read. Then you can see the value from the PLC. We're going to also show an example of writing to the same instance and drive parameter home.dist, and you would look it up the same method. We're going to use 200, the 32-bit version, and 4 bytes signed. So then if you were to add another rung with another MSG instruction, then for the write you would also use a message type of SIP generic, the service type parameter write. Service code would be 10 hex, class F hex, attribute 1 hex, and then the instance number will be, in this example, 200. The source element to the write is the tag that holds the value that we want to write to that instance, and because instance 200 is a 4 byte instance, you'll notice that the source length is set to 4 bytes. The source element tag is also declared as a double int, or 4 bytes. And now we're going to do a demonstration of using explicit messaging to read or write to the home.distance parameter. For this demonstration, I'm going to start in the RSLogix 5000 programming environment. I'm going to add 2 rungs, and then on each rung from the element group input and output, I'm going to add an MSG instruction on both of these rungs. To set up the MSG instruction, I have to click here, right click, and give it a tag instance name. So in this case, I'm going to say it's going to be the home dist write MSG. And I'm going to call this something similar, home dist read MSG. Okay, before we configure it, we can set up the triggering and the execution logic. The MSG block has an enable, a done, and an error. So similar to our best practices with our add-on instructions, I'm going to add a trigger, a one-shot, do a parallel branch around it, and we'll have normally open and to normally close. So now in the branch I can say home dist write msg dot en for the enable. I can do home dist write msg done and home dist write msg dot error. I'm going to have a new tag. I'm going to call it home dist write MSG trigger. I'm going to have a tag for the one shot MDWM home distance write MSG one shot. And so that's set up, and we're going to do the same thing for the other rung. Okay, so we've got the method for triggering each one of these, so now we just need to configure it properly. In order to view the configuration dialog, there's a button here on the MSG instruction, so I click on it. And this screen should look familiar to you because we covered this in some of the previous slides in this presentation. So the message type is SIP generic, and if I click the service type list box, what I want is the parameter right. So when you choose that, the service code, class, and attribute all get filled in for you. And the only thing that you really have to enter here is you need to point to the instance number, which we had determined that it's instance 200. Now, instance 200 was 4 bytes, so I have to set the source length. And the source element will be a tag that holds the value that we want to write when this instruction is triggered. So there's a button here called new tag, so I click on it, and I'm just going to call this home distance MSG write value. And you'll notice that I left it as a double int because this is a 4 byte parameter. So then you have to select it from the list. So if I go down here, double int, click, it gets filled in. So there's one more step that we have to do here to configure it. So from the communication, there's a path that's required. If I browse, you'll notice that in this project, the AKD generic Ethernet module is already declared, so that's what we have to point to for this particular axis. If you have multiple axes, then you would point to the one that this MSG block is applicable to do the explicit messaging. And so that's all we really have to do to configure this. So I'm going to say apply, OK, and we're going to do the same thing for the MSG block that's intended to read. We're going to choose the service type. We're going to look down, parameter read. It fills in the service code, class, and attribute for you. We want to read instance 200. Now in this case, we don't have a source element or length because we're not going to source a value from the PLC. In this case, we're going to get a value or read a value when we trigger this instruction. So all we really need is a destination. We need a tag to hold the value that is read using the explicit messaging. So I'm going to click on new tag. It's going to be a double int because again, instance 200 is 4 bytes. I'm going to call this home dist MSG read value. Create. Now I have to choose it. Read value. So then again, we have one more thing that we need to do. We have to go to the communication tab. We have to choose the correct target drive. So OK, apply, OK, and now we're done. So now we're ready. We can save the project. If I wanted to check it, and that's normal, there's no errors, it's just 2 warnings. So now I'm going to download this project to my PLC. Okay, so now we're ready to try it. Go back to Workbench, and I'm online with the AKD Ethernet IP drive, and what we want to do is under Access, we're going to go to the home screen, and I'm going to start out by this parameter being 0 as a starting point, and then we can see the value change from there. So moving back to the PLC, we're ready to trigger these and observe them in execution and working. What I'm going to do for convenience for this demonstration is I'm going to go to the watch, and I'm just going to do a quick watch so it's easy to set the value and read the value and see the tags change. So we're going to say home distance. I'm going to do the right value first, and home distance, read value. So those are the two. I'm going to set this to a value of 1, 2, 3, 4, 5 just for demonstration, and this is going to be our read value, so we don't need to set anything there. So now I'm going to trigger or toggle the trigger. It enabled, and now it's done, so we know it executed. If I go to Workbench, you can see that 1, 2, 3, 4, 5 was written to this particular parameter, so we know it worked. Now I'm going to read it back, so going back to the PLC, I'm going to move down here. I'm going to toggle the bit or trigger, enable, and done, and you can see that it read the value back. And that is how explicit messaging works.